All right, so we're talking about systems of equations, which means you have a set of two or more equations used to solve for two or more variables. So what it is it's two equations where the x in both equations equals the same number, and you try to find a number that will fit the y's as well in both equations. So we have three methods of solving these. The first one is graphing. So that's the one we're going to practice today. It is not the most reliable method because, if your solution is like something like 2.3, it's really hard to see that on a graph. Also, students tend to not like graphing, so it would not be their first choice of pulling out a piece of graph paper and solving, but it is definitely a method that can be used. So this is what we're going to talk about today. So this is giving you an example of two equations that have been graphed. So the equation 1, this one, line 1, was y equals 2x minus 3. Okay, remember -3 is your y-intercept. So that's why it crosses the y-axis at -3. +2 is your slope. So we went up 2 to the right 1. So remember, slope is rise over run. The second equation, so this line up here, that equation is y equals -1/2 x plus 7. So y-intercept is at +7. My slope is -1/2, so I go down 1 to the right 2. So then we have points that we can draw our lines, okay? Now, where they intersect here, that is your solution to the system. So here's my system. I'm trying to figure out what x could equal in both of these equations so they both equal the same y. So the solution or answer to the system of equations is the point where both lines intersect. Okay, so in this case, this solution is, we went over 4 and up 5. So my solution is 4, 5. So that means that x is 4 in both equations. That means y would be 5 in both equations. Now, just like we had with regular equations, we do have different types of solutions. When they intersect just one time, that means we have one solution. When we have parallel lines, they're never intersecting. That means no solution. And then this looks like one line, but it's actually one line on top of the other, so that it's exactly the same line. So that means every x and y is the exact same. So this is infinite solutions. Okay, so that's what it would look like when graphing. All right, so we're just going to practice some of these. All right, so on this first one, this is +2, so I'm going to put a point at +2. My slope is -1/2. So the negative can go on the top with the 1, or the negative can go on the bottom with the 2. But it can never go on both. If it goes on both, then you change this to a positive slope, because a negative divided by a negative would be a positive. All right, so I typically stick with my top one. I put the negative with my top one, so I'm going to go down 1 and to the right 2. Down 1 to the right 2. I can make up a few points to help me draw my line. We're going to use a straight edge to draw our line. Okay, there's our first line. All right, so then the second line, I'm starting at -3. Now my slope is -7/4 or 7/-4. Now in this case, I can't go down 7, so I can't make the 7 negative. So I'm going to have to use this one where I make the 7 positive and the 4 negative. So this is going to tell me up 1, 2, 3, 4, 5, 6, 7. And I'm going to go to the left 4. 1, 2, 3, 4. So then connect these points, and we can already tell where these 2 points are going to connect, or where they're going to intersect. It's going to be right here. So we write that our solution here, we went to -4 and up to +4. So parentheses, -4, +4. Make sure you have the comma in between because we're writing a coordinate point. So what this is saying is if I plug -4 in for x right here, I would get 4 for y. And if I plug in -4 right here, I would also get +4 for y. Okay? All right, the only time that these can get a little bit tricky is when your equation is not in slope-intercept form. So remember that slope-intercept form is that y equals mx plus b. So this is your slope and b is your y-intercept. Now, when you're in this form right here, it's not y equals, so we cannot graph right away. So what we need to do is we need to solve these for y. Then we can graph. Okay, so I'm going to do that right below here. So on this first equation, I have 2x plus 3y equals -3. So my first step is going to be to move the x. So I'm going to subtract 2x from both sides. These cancel, so then I have 3y equals, now, -3 and -2x I cannot combine because they're not like terms. So I'm just going to write this as -3 minus 2x. Step 2, you divide by the number with y. So I'm going to divide by 3, and we divide every piece by 3. So then we have y equals -3 over 3 is -1 minus 2/3 x. Okay, remember we don't do decimals, so it's going to stay like that. All right, so then if I look at the second equation here, so I have 2x minus 3y equals -9. Start with step 1, move the x, so minus 2x from both sides. So -3y equals -9 minus 2x, and then divide by -3. So these would cancel. I'd have y equals -9 divided by -3 is +3. -2 divided by -3 becomes +2/3 x. Okay, so now these are the two equations that I'm going to graph. So this one, my y-intercept starts at -1. My slope is -2 over 3. So I'm going to go down 2 to the right 3. So it would kind of be over there. I'm going to connect these points. There we go. You do want to use a straight edge in order to connect your points. If you don't have a ruler, you can use the side of a notebook, a binder, your phone, whatever, a folder, anything will really work. And notice how I draw my line all the way through. We're not stopping it short because we're trying to find an intersection point. So my second equation, I'm going to start at +3. And then my slope is a +2/3. So up 2 to the right 3. So then I will draw this line. So that right there would be my intersection point. So we would have solution at -3, 1. Again, that means -3 would go in for x, +1 would go in for y, and this first equation would equal -3. And the second equation, I put -3 in for x and put a +1 in for y, and my solution would still be -9. Okay, so this is my solution here. All right, so that's the basics for graphing. If you have any questions, please feel free to reach out. Thanks.